Welcome to Flying High in the Classroom Using Drones by Dr. Wosczyna-Birch and Eric Flynn. We'll start by giving a brief overview of the Connecticut College of Technology and the Regional Center for Next Generation Manufacturing to give you an idea of the programs that exist and funding that has helped some of these initiatives and partnerships. The College of Technology was created by Connecticut legislation in 1995 during the merger of its technical and community colleges, and it was established by a higher education council that was created during that merger. The purpose of the COT is to create seamless pathways between community colleges and universities and technical high schools. Articulation agreements are in place for engineering and technology programs, and we'll go over that curriculum in a little bit. The COT also is able to respond to workforce needs regionally and statewide through these community college programs. The leadership of the COT is the College of Technology Site Coordinators Council, and that consists of deans and faculty from community colleges, state and private universities, high schools, nonprofit organizations, business and industry, and consultants when certain projects require it. As noted in the previous slide, the College of Technology is led by the statewide Site Coordinators Council. This council meets monthly during the academic year, and we average about 25 attendees per meeting when they're in person. Once the COVID-19 pandemic hit and we went to virtual meetings, attendance has ranged from 40 to 45 participants per meeting, and more partners are just able to join because of that, because of the nature of those virtual meetings. When the meetings are on ground, they're hosted at community college and university partner campuses, so they can include tours of the campus and specifically labs and facilities for engineering and technology. During these meetings, we disseminate initiatives for students and faculty that are going on, both upcoming programs and the impacts of previous programs. We also discuss any curriculum pathways within our COT programs, and all programs that come through the community colleges for engineering and technology, and including manufacturing, have to be approved by the COT first before they go through our Board of Regents review process. This ensures that our core curriculum is followed and we're all on the same page with that curriculum, and the students are receiving the same education within the community colleges that transfers into those university partners. As you can see here, this is a map of Connecticut, and this demonstrates our College of Technology, community college, and university partners in the state. We are a very well-defined statewide initiative reaching all corners of the state. There are also programs in place in the community colleges so that if one college doesn't offer a certain course, you can take that at another community college. But there's a wide variety of programs, and as I said, our engineering, science, and technology studies programs do respond to regional industry needs within the state. And now I'll talk about our National Science Foundation Advanced Technological Education, or NSF-ATE funding. This is the funding that provides the initiatives that I'll be talking about shortly, so I just wanted to touch base on that. The College of Technology did receive funding in 2004 to create the Regional Center for Next Generation Manufacturing. It also received funding in 2009 and 2012 to expand that center, and then in 2019 received funding to transition into a resource center. Some exciting news this year in 2021, we also received funding to become the National Center for Next Generation Manufacturing under the NSF-ATE program. This will be the only NSF-ATE center for manufacturing. For all of this funding, recruitment and retention of underserved and underrepresented populations is always a goal or objective. We also work to provide degrees and credentials for workforce readiness, and the COT has been recognized as a national model. Under this funding, we've also received international supplements for collaboration with Germany and France. The COT was also named High Tech's Innovative Program of the Year last year in 2020. And the work of the COT and the Center for Next Generation Manufacturing has been recognized in several reports, including an MIT study, a New England Council and Deloitte report on advanced manufacturing education, and it's been cited in our Connecticut Business and Industry Association's manufacturing report, actually for the past couple years.
Hi everyone, this is Eric Flynn, the Principal Investigator of the MET² program. MET² is our Mechanical and Manufacturing Engineering Technologies for Energy and Sustainability. It's about 4 years in now program. We're past our funding with the National Science Foundation, but have continued some funding with the Regional Center for Next Generation Manufacturing. It's a great program. We bring in community college and university students from across the state of Connecticut with all fields of engineering backgrounds. So we'll have electrical engineers with biomedical engineers, computer engineers, manufacturing engineers, mechanical engineers, and then some of their offshoots. And what we do is we pair the community college students with the university students, and we create and distribute these real-world engineering challenges that are brought to us by industry, other faculty at universities, and some faculty at the community college, local entrepreneurs, just about anybody. And what's unique about the program, I believe, is that the students choose the projects that they are going to participate on. That way we really can grab the passion of the students and what they're interested in their future, in their careers, and they can find again, an engineering challenge based on their interests. And we do it every winter. We have a 2-week session throughout the winter, and then we carry it on into the spring semester when the teams carry out their projects. Then at the end of the spring semester, we have a annual presentation that brings all the teams together and all the partners together, and the schools and colleges and industry, and we have a really nice, a presentation day. And again, in the 2020 program, 20 student participants, and we also just completed our virtual program as well. What I think is really unique about what we do over the winter intersession for the MET² skill sets is that we really combine business and professional skills with traditional engineering skills. So for example, in terms of the technical skills they learn, is we introduce them to SolidWorks, essentially a CAD package, and on top of that we give them a 1-year educational license for SolidWorks, because not only is it important over the winter intersession, it's also important during their spring semester. And again, CAD software is important just about for every discipline of engineering. So it's a great excuse to get them in front of that software. We also talk about 3D printing and rapid prototyping. We also touch upon CNC machining, even though not every college we partner with has those capabilities. The beauty of the program is that we do pull from the resources of each individual college, so it's important to touch upon that type of technology as well. And one of our newer technologies that actually, if we can find anything good to say about the pandemic, was that because everything went virtual, it was a great time to introduce virtual reality, or maybe I should say augmented reality, in terms of technology such as the Oculus Rift, where virtual manufacturing environments were introduced and virtual assembly environments were introduced that you could implement directly from the CAD software. So we also do a little bit of programming with Arduinos, and again, we touch upon just about everything in terms of the manufacturing processes to bring a prototype to full production. On the business side of things, we introduce principles to engineers that they might not see until a corporate environment, so we get ahead of the game on that. such as business modeling, IP, networking, mentoring, and the whole idea of what it's like to get a patent and protect your work. And then even more of the professional skills would be the DISC profile, patterns, emotional quotient, and dealing with difficult people. I mean, all of this is well documented, and we bring in experts that are experts in their field to talk about these types of skills. So the engineers stick with the technical skills, and then we have our business partners deal with the professional skills. So it's a really nice balance. I must say I'm really proud of this UAV project. This was one of the original projects we started with. This was also sponsored by NASA. And what I like about it is this was really back before 3D printers were commercially available, where everyone had one. This was right when the technology was new, and what the challenge was how do we use 3D printing in a way that we're not just replicating traditional manufacturing processes, but how do we think outside the box? How do we come up with new design methodologies that take advantage of what 3D printing is? So one of the best things I could think of was a UAV, or now we obviously call them drones, but it took advantage of the fact that we could make shapes and volumes and geometries that would be almost impossible to make through conventional manufacturing methods, and would take advantage of 3D printing and additive manufacturing. And what you're seeing right here highlighted is an arm structure that was, you could click into the base, and that way if you had a crash with the drone, well, you can go back and you can 3D print another arm and you just snap it into place. And another, again, design cue that takes advantage of the additive manufacturing was that you had a hollow structure with a triangular truss system to feed the wires, but also remain as light and as strong as possible. And here you can see Design 2.0, just more of, we added some bells and whistles where we could incorporate a GoPro camera system as light as possible with a articulated frame. Again, there's more close-ups of the arm structure, and it was quite a large build. I mean, we're talking something that was maybe almost about 1 meter across, but light enough, again, to take off, have a pretty decent flight time, have repairable options. And this was completely designed by about a team of 6 students with me as the advisor. And again, also sponsored by the Connecticut NASA Space Program. And just for the fun of it, here we're almost looking at a design failure, but that's part of the process, part of the learning curve. They wanted to pretty much encase the propeller system, but unfortunately, even though it's a really good-looking design, it added just too much weight, and we found that out. And again, that's something you can't do with just CAD software. It really needed to be printed out, held, measured, and no matter what they did, a few design iterations, it just became too heavy. So even though the design was valid to protect the propeller system, we just couldn't get the weight to where we needed it. So a future design, possibly, a more protective design, definitely, but at the moment, without a complete redesign of the other structures to lighten the system, they decided we just couldn't do it. But it was still a good process, a good example, good challenge. And obviously this will just be a video of it taking off and doing its thing. And there's one of the design teams right there. This is great. Enjoy the video. So the Engineering Technology Challenge, ETC, is essentially a spin-off of Met Squared for the high school students. We do the same type of ideas. We bring in high school students from the inner city, and we challenge them with engineering skills and engineering designs. It's a skill-based curriculum that really focuses on team building and leadership and other professional skills. We still use DISC and emotional quotient and all of the topics we cover in Met Squared, again taught by the experts that we use in Met Squared. But we also bring in a different team of technical advisors, but we still focus on things that are crucial, critical to a good engineering program. Again, SolidWorks, coding, and we code drones. It's funny when I say code drones. We actually use co-drones. That's the name of our brand, of their brand, the co-drone. And it's a great kit. So instead of 3D printing the entire drone, the entire UAV, we purchase co-drones that come with Arduino-based programming. And this way the kids have something that they can build with their hands, but quicker. It doesn't take a whole semester. It takes one Saturday, and then they program it the next Saturday, test fly it the next Saturday, and then create an autonomous program the Saturday after that. And this way we can make sure it fits within our 5 or 6 week program. We also incorporate technical writing. They have to document their results, math of course, because they're calculating some of the stresses and some of the geometries that we create. It's again hosted at the community college, so we bring the students in on a bus and we feed them, and they're ours from about 9 a.m. to 3 p.m. every Saturday for 5 weekends. And again, you can see that we do have quite a number of participants. We always keep it around 24, 25 because that's pretty much the size of our computer labs as well, and that way every student gets a computer, so every student is in front of the CAD and in front of Microsoft Office and in front of Arduino programming. And we also did virtual programs where we sent them their own Chromebook and we did everything virtual. We did virtual programming, and we introduced, instead of Arduino, we introduced the microbit programming kit. Now, on top of some of the other topics we've mentioned, if we're talking drones specifically, well, then participants learn about the applications. Why are drones used throughout various industries? We talk about government applications, military applications, civilian applications, retail applications. So we go through that. We kind of introduce why they're so important in our world these days. We go through the mechanical and electrical components of drones and their functions. We talk about all the terms in terms of flight, yaw control and roll and pitch. We talk about Arduino microcontrollers. We don't just throw them into the drones. We actually introduce Arduino microcontrollers first and how to code them, and the whole introduction to blinking an LED, to hooking up the USB and getting the operating environment there before they even touch the drone. And then we also do these types of programs with high school faculty. So we show teachers how to present these drone projects in the classroom. Some of our activities, again, include, they're going to build these drones from scratch using the kits. They're also going to disassemble them at the end of the program so they're ready for the next group. But they program them, they, again, manually fly them, and then they write small coded programs to autonomously fly them, from takeoff to doing a few maneuvers and landing, all throughout the software. As I mentioned, we use the co-drone by RoboLink. We've had great success with this. They're pretty resilient. It might be hard to tell by just the photo alone, but that drone itself could pretty much fit in the palm of your hands. Again, very resilient. We've crashed them into the ceiling, we've crashed them into the wall, we've crashed them into the floor, and we've crashed them into each other, and they keep going pretty strong. We've purchased replacement parts, but honestly, unless it's a catastrophic failure, these things will keep on going. Very easy to fix, very easy to replace. Battery lasts well. The Bluetooth is pretty good. We've had a good number of drones flying at the same time with very little interference. So they've been fun. They've been good. And again, they use the Arduino microcontroller programming language. So it's a good excuse to teach both at the same time. And what we have here is just basically the breakdown of the ETC technical curriculum week by week. Again, it's a 5 or 6 week program. We've pretty much got it down to 5. It seems to work best for the high schools and the students and everyone involved. But as you can see, again, we've spaced it out where before they're even touching the drones, they're introduced to the programming languages and the Arduino microcontroller and Bluetooth and Wi-Fi and what's the difference. But they're also starting to look at the individual components of the code drone. In week 2, we're given a little bit more math skills, and they start to see CAD software because we want them to think, how could you redesign a part on this drone? Well, what are you going to use the CAD software to make? What if you could 3D print anything to fix this drone or make it your own? What would you do? And that same week, they're putting the drones together and they're manufacturing their parts. Week 3, again, more math, but we also introduce them to digital electronics and binary systems and analog versus digital, because as we all know, right, the drone and the programming is a digital system. And even though we can introduce them to series circuits and parallel circuits, what's more important is usually introducing them to ones and zeros and how programmings are put together like that. This in the same week, they're also loading up the software, introduced to the Arduino IDE, programming their code drones, and starting to take them off. Week 4, we have more computer technology, such as the processors, the memory, the storage, the graphics. Why do these systems work together in unity? Again, they're programming more of the drones, they're trying new programs, they're flying them, they're trying to accomplish tasks with the drones. And finally, week 5, a little bit of data analysis and statistics. And now this is where all their challenges come together. They're trying to navigate through a virtual environment that we lay out in the school, and it's usually time-based, so that way there can be a competition. They're flying them manually, they're programming them, they're trying to get them to do autonomous tasks, and it's a lot of fun, because here's where you have the crashes and sometimes the successes, and the teams working together to put their drones back together to recompete in the challenge. So really nice. Thanks so much.
The College of Technology and Center for Next Generation Manufacturing hold 2 different types of professional development activities during the year. These are for community college and high school faculty. And the Summer Teacher Workshop is a 4-day, for the past 2 years, virtual workshop, and this is held for participants from across the United States. And it covers, like the student programs, both technical and professional skills. The professional skills include the same ones that were in the student program, including team building using behavioral diversity and the DISC model, emotional quotient, dealing with difficult people, strategic management process, time management, goal setting, and advanced memory techniques. The technical skills include SolidWorks, 3D printing, and the programming of coding and drones, and now we've also added the BBC microbit for learning coding and programming. And educators that participate in this are encouraged to develop curriculum that incorporates professional and technical skills learned during the workshop into their home institutions and classrooms. The second one is the one you're participating in right now, and that's the SMARTT Manufacturing Workshop, which focuses on the programming of the RoboLink Mini code drone and industry applications of smart manufacturing. We did hold one of these at Texas Community College a couple years ago in person, and then due to the pandemic last year and this year are virtual as well. And that concludes our presentation. Thank you for listening to our overview of how we incorporate smart manufacturing into our student and educator programs that are supported by National Science Foundation and Advanced Technological Education funding. Our contact information is on the screen if you have any questions. Again, Dr. Karen Wosczyna-Birch, Principal Investigator and Executive Director of the Connecticut College of Technology and Center for Next Generation Manufacturing. Wendy Robichaud is the Project Manager for the College of Technology and Center for Next Generation Manufacturing. And Eric Flynn is Department Chair of Engineering and Applied Technologies at Gateway Community College and the technical lead for the initiatives that were described in today's presentation. Thank you.